boys and girls, it's Miss Bissell. We are on page 462 of our textbook, and we're going to be talking about developing a volume formula today with a lesson again, 11.2. So yesterday we were introduced to volume, and we learned that volume is the number of cubic units that we need to pack a solid figure without gaps or overlays. And we looked at rectangular prisms, we looked at special rectangular prisms called cubes, and we basically counted the unit cubes that we could see. We figured out how many were on each layer, and we multiplied that by the number of layers. Today we're going to be working with two different formulas, and our essential question that's going to guide us through the lesson and that we need to be able to answer by the end of the lesson is, how can you use a formula to find the volume of a rectangular prism? All right, so we are going to find the volume of the rectangular prism if each cubic unit represents 1 cubic foot. So that means that each of these cubes' edges is 1 foot, and the volume of each of those unit cubes is 1 cubic foot. So we want to know what would be the volume of the whole rectangular prism. All right, the 5th grade helper says you can find the volume of a rectangular prism by counting cubes or using a formula. And she tells us that a formula is a rule that uses symbols to relate two or more quantities. All right, now look at these different rectangular prisms. The difference with the rectangular prisms that we look at today is that we don't see the unit cube lines. So we're not going to be able to count them. All right, so we're going to use formulas. And if the dimensions of a rectangular prism are given as the length L, the width W, and the height H, then we're going to use this formula to find the volume. Volume equals length times width times height. And it's abbreviated V for volume equals L times W times H. Length, width, height. So we look at our rectangular prism and we see that the length is neatly labeled for us as 6 feet. The width is 4 feet, and the height is 3 feet. So we plug in the known values. So we're looking for the volume. So the V stays the V. We plug in a 6 for the length, a 4 for the width, and a 3 for the height. And we multiply each of those 3 dimensions. Now, they did go around and put parentheses around the 6 and the 4 because you're going to pick 2 of the numbers to multiply together first. So 6 times 4 is 24. So that's why the parentheses dropped. And now we have 24 times 3. And when you multiply 24 times 3, you get 72. So the volume of this rectangular prism is 72 cubic feet. And don't forget, we can abbreviate it with the exponent in the air, the little 3 for cubic units. All right, another formula for the volume of a rectangle is volume equals base times height. V equals B times H. We were using that pretty much yesterday. If you would remember, if this was yesterday's assignment and we were trying to figure out how many cubic units were in this particular rectangular prism, if you remember, I was counting the length, how many units were across the front. And in this case, we have 6. Then I was counting how many were in the width of it. There are 4 here. And if you remember, I multiplied those together, 6 times 4, to figure out how many unit cubes were in one layer. And then once I knew how many unit cubes were in each layer, that would have been called the base. And then we multiplied it times the height, or how many layers there were. So height is another word for how many layers are in your rectangular prism. All right, so let's take a look at this one. They're telling us that the base is 24 units, and it's actually 24 square units, okay? So when we look at this, the length times the width gave us 24. The 6 times the 4 gave us the 24. And we know that this is a base, not only because they tell us, but if you see the exponent 2, then it means they're giving you the area. And area is when somebody's already measured the length and the width by multiplying them together. So they've already done pretty much one step over here. So the base is 24 square feet. The height is 3. So we're going to multiply 24 times 3, 72 cubic feet. All right, let's take a look at the convince me. Now, I just want to remind you that you are watching me on video, so that means you have the option of pausing at any time, rewinding, watching something again if I'm going too fast, or if you think you understood something but you want to listen to it again just to give yourself a chance to make sure you thoroughly understand. So take advantage of that. Just remember that we're watching videos and we're doing our work remotely, so we don't get behind, so we learn new concepts, and so we master the concepts. We're not working just to have busy work, just to be done. We're building a foundation for everything you're going to do the rest of this year in 5th grade, and from which you're going to build your concepts, math concepts next year in 6th grade. All right, so the convince me on the bottom of page 462. Give the dimensions of a different rectangular prism that also has a volume of 72 cubic feet. And then we need to explain how we decided that. So basically, I need to be able to multiply, think about it, 3 numbers to give me 72. And we don't want to use the 6, the 4, and the 3. So I know that because here's my basic formula. Volume equals length times width times height. Okay. And what I'm thinking is I'm going to think of 2 numbers that I could multiply together to give me 72. And I'm thinking about 9 times 8. So this is my thought process. 9 times 8 is 72. So if I take this 9 and break it down, then I could do this. I could say the length is 3, the width is 3, and the height is 8. Now, basically what I just did was I thought about 2 numbers that would give me 72, because I need 72 cubic feet, but I had to break one of those numbers into 2 factors so that I would have a length, a width, and a height. Now, 3 times 3 is 9. 9 times 8 is 72. So this is where I get 72 cubic feet. All right. And if you think about what that would look like, then we would have our 3 units. Right here we would have our 3 units. And we'd go 1, 2, going up 8 units high. So it'd be a tall prism. Sorry, I'm not that good at drawing. Anyways, you get the gist of it. Okay, looks something like that. All right, let's go on to page 463 and let's look at number 1. And we're just going to talk about it. In the example on page 462, could you first multiply the width by the height? All right, what we did was on the example on page 462, we multiplied the length times the width first. So they want to know, could you multiply the width by the height first? And what do you guys think? Think about your properties of multiplication. And the answer would be yes, you could do that. Multiplication is associative. So you can multiply the factors in a different order and you're still going to get the same product. So what we're talking about is we looked at this, 6 times 4 being multiplied first times 3. And we got 24 times 3. So that gave us 72 cubic feet. Okay. But if we did this and we multiplied the width times the height, it just changes it a little bit. We'd be multiplying 6 times 12. That still is going to give us that 72 cubic feet. And that's because multiplication is associative, meaning you can change the factors in a different order, but when you multiply them, you're going to still get the same answer called a product. Okay? All right. A wooden block measures 5 centimeters tall, 3 centimeters wide, and 2 centimeters long. The area of the base is 6 centimeters. Draw a rectangular prism to show the block and label it. What is the volume of the block? So I noticed they gave us kind of too much information. We have 5 centimeters high, that's the tall, means high, 3 centimeters wide, 2 centimeters long, and the base is 6 centimeters. Well, you get the 6 centimeters by multiplying the length times the width. So we really don't need that extra information. So if I were to draw this, we have 2 centimeters is the length. The width is 3. Okay. And the height is 5 centimeters. So here's my front face. Here would be my side. And there would be my top. It's not drawn very good today. There we go. So we have 2 centimeters long, 3 centimeters wide, 5 centimeters high. And to solve it, we always write the formula first. Length times width times height. Our length was 2. Our width was 3. Our height was 5. If we multiply the length times the width, that's where they were telling us that the base is 6. And 6 times 5 gives us 30 cubic centimeters for the volume. Okay, so 30 unit cubes or 30 centimeter cubes would fit inside this rectangular prism. All right, so in number 3 and 4, we're going to find the volume of the rectangular prisms. So we need to think about which formula do we need to use. And I'm looking at number 3, and since I'm giving a length measurement, a width measurement, and a height measurement, I'm going to use the formula volume equals length times width times height. Then I'm going to plug in my known values. I'm searching for the volume. The length is 9 centimeters. The width is 2. We're at inches now. And the height is 4. Okay. I'm going to pick 2 that are easy to multiply right here. I know that I'll bring down the 9 and the times. 2 times 4 is 8. So I'm ready to solve. The volume of this rectangular prism in yellow is 72 cubic inches, or 72 inches cubed. All right, in number 4, I'm going to use the volume equals base times height formula. And the reason I'm going to do that is they've shaded in what this rectangular prism's sitting on, which is the base. And they've gotten the base for me already by multiplying the length times the width and filling that in and telling me that that's 24 square yards. So I'm going to plug in I'm going to write my formula first. Volume equals base times height. I'm going to fill in my known values. So the base is 24. The height is 9. And then I'm just going to sit over here on the side neatly, and I'm going to multiply 24 times 9. 9 times 4 I know is 36. 9 times 2 is 18 plus the 3. So I get 21. So 216. These are yards. So what I have are 216 cubic yards for volume. So that means that 216 1-yard cubes would fit in there. So that'd be a pretty big rectangular prism. All right, we're going to take a look at the 6 problems at the bottom of the page. So I'm going to ask you to go ahead and pause your video. I want you to work these out. Give you a hint. If they give you the 3 dimensions, just like they did in number 3, you're going to use your length times width times height formula. If they give you a square unit measurement that is shaded in for the base, and then they only gave you the height measurement with it, then you're going to use the measurement formula, volume equals base times height, like we did in number 4. So go ahead and pause your video, and then we can talk about each of these. All right, here's my work and the solutions to each problem. So number 5, I'm using the volume equals length times width times height formula. I plug in my values, 7 for the length, 4 for the width, 3 for the height. I chose to multiply 4 times 3 first, so I put the parentheses around it. When I multiply, I still have 7 times 12. 12 times 7 is 84. I'm working with centimeters, so it's 84 cubic centimeters. Number 6, the answer is 80 cubic inches. And I'm using the volume equals length times width times height formula. The length is 4, the width is 4, and the height is 5. And we're working with inches. I chose to multiply 4 times 5 to get 20 because I know 20 times 4 it pretty easily can be multiplied without doing any scratch work to get 80 cubic inches. Number 7, this is your base times height formula. The base is 52 cubic meters. So square meters. So 52 square meters fit in the base. 52 little squares that measure 2 meters by 2 meters, pretty big. And the height is 3. So 52 times 3, and I just did a little bit of math in my head, and I got 156 cubic meters. 3 times 5, or 50 is 150, 3 times 2 is 6. I just kind of did some mental math there. Number 8, you also use the base times height formula. The base is 64 square centimeters. The height is 4. You multiply those together. When you do, you get 256 cubic centimeters. I did a little bit of work out to the side. So right there, nice, small, and neat is my scratch work. And it doesn't interfere with you being able to look at my work, right? So keep that in mind when you're doing your work. Keep it nice and neat. All right, number 9, you're back to the volume equals length times width times height formula. This is actually a cube, and I know that because the length, width, and height are all the same measurement, 7 meters. So I fill in the values, plug them in, 7 times 7 times 7, 49 times 7, I get 343 cubic meters. And the last one, we're using the base times height formula. The base is 153 square feet. I multiply it times the height of 7 feet. Had to do a little scratch work on the side. I get 1,071 cubic feet. All right, hope you did well on those. All right, real quick, let's flip over to the back and let's look at number 11. I do want to look at this really quickly. The dictionary is 3 inches thick. What is the volume? So first of all, I want you to think about the formula you're going to use. I see a measurement along this line that's 7, along this one that's 9. So I'm going to go with, if the thickness here is 3 inches, I'm going to go with volume equals length times width times height. So we always, boys and girls, write the formula. Then we plug in the values. So it doesn't matter what measurement we call the length, the width, or the height because of multiplication being associative, and it doesn't matter what order we multiply these in. So I'm just going to use the length as 7, the width as, the width is 3, and the height as 9. All right, then I'm going to multiply, and I know that 7 times 3 is 21. I'm going to multiply that times 9. Just going to step out to the side, do some quick math here. 9 times 1 is 9. 9 times 2 is 18. So the volume of this book or this dictionary would be 189 cubic inches. All right. And why don't we look at number 15? Number 15, we're going to choose all the expressions that could be used to find the volume of this wooden box. So let's take a look at the box. They've given us 3 dimensions. It looks like we have a length, looks like we have a width, and this looks like the height of it. Again, it doesn't matter what order it's in. We just have to have all three, and they have to be multiplied together. So let's take a look at this first one. 6 times 4 times 3. It doesn't matter which two we multiply first, so it really doesn't matter where the parentheses are. The main thing is, do we have a measurement of 6, a measurement of 4, a measurement of 3, and are they all multiplied together? They are, so I'm going to choose this as one of the possible answers. All right, let's look at the next one. We start out the same, so we're doing well, but we have one problem. Do you guys see it? You don't add 3 inches for the height. You've got to multiply it by 3 inches. So this is not going to work just because the sign is wrong. The operation is wrong. After you multiply the 6 times 4, you then multiply that times the 3. You don't add 3 to it. All right, same thing here. We have something wrong. 6 times 4 would just give us the base. We don't have the third dimension, so we wouldn't be finding volume if we multiplied 6 times 4. All right, let's take a look at the next one. We have 6 times 4 times 3. Well, this would give us our volume. It doesn't matter what order they're in, just so we have these 3 dimensions as factors, and it doesn't matter which of the two we multiply first. All right. And the last one we have 24 times 3. Now, wait a minute. That only has 2 numbers. But unlike this one, where the 2 numbers are just 2 of the dimensions, this one has 1 of the dimensions and 24. So 3 would account for the height. 24. If I can multiply 6 times 4 and that equals 24, then this is really using the base times the height, isn't it? Isn't this the formula that would be volume equals base times height? Because 6 times 4 would give us 24, the base. So yes, this one right here would also work. All right, boys and girls. So let's review our essential question. How can you use a formula to find the volume of a rectangular prism? And I think what we have learned through this quick little lesson is that you are going to use volume equals length times width times height if you are given those 3 dimensions, or if you can count unit cubes to figure them out on your own, like in this problem. Or we can use volume equals base times height if we have a square unit measurement and a height measurement, because that would mean that somebody's already figured the base for us. They've already multiplied the length times the width. All we have to do is take that base, which is a square unit, and multiply it times the height to build that third dimension, or to build that height in that rectangular prism. All right, you guys are going to have a practice buddy to work on. I'm just going to remind you, you need to have a sheet of paper headed, lesson 11-2. You probably want to head it just like it is on page 461. I think it says develop a volume formula. You can write that you're doing the practice buddy and work out the problems. We are not speeding through this to get problems, done and without concern for accuracy. We want to make sure we understand the concepts that we're learning in math. We want to make sure that we are giving our best effort. So I get it, when you're working online and doing math, it's tempting just to push buttons and be done with it, but we're working for accuracy. So I do want you to head your paper. I want you to work out your problems, and I'd like you to click all these practice buddy work papers that I'm asking you to head in your binder behind math work. That way, if I see that you are struggling with a concept, I can ask to see your work and analyze what's going on, figure out what you're doing wrong and what you need to do to fix that problem. All right, boys and girls, I hope you have a wonderful day, and I will see you tomorrow.